All right, so today we're going to be looking at an interesting derivative. We're going to be taking the derivative of x to the power of x. We're calling this live because I didn't practice beforehand how to work this out. So I'm just going to go through the process live. This is a derivative I've done before, but it's not one I do all the time. It's probably been a couple of years since I did this derivative, so it's not like I know exactly what to do. So this is a good type of problem to do in a live fashion. And the thing with derivative problems, it's not like integration where you have all these different techniques like integration by parts and U substitution and trigonometric substitution. Derivative, there's really only one technique, and that's the chain rule. Other than that, when it's an interesting derivative, it's applications of things you learned in earlier math courses in your pre-calculus, in your algebra 2, and so forth, to be able to manipulate the problem. So I'm going to go ahead and try this and see what happens. I know I will solve, whether I get it on the first strategy I try or not. We'll see. It's all about the learning process. So I wanted to make sure you can see me go through this particular process. All right, so what I want to do here is I want to write this as y equals x to the power of x. And I want to rewrite this in logarithm form. So just to remind you, for instance, the log base 8 of 512 is 3. And in exponential form, it's 8 cubed equals 512. So logarithms are created to find exponents. So a logarithm, it's going to equal an exponent, and the number that's being raised to the exponent is the base. So for this particular problem, this will be the log base x of y equals x. Okay, so right there, it doesn't look like it's going to do anything tremendously good. And so what I'm going to do is use the change of base formula to put this as ln y over ln x. And that may prove to be beneficial. So let's say I write it down here. So I'll put the x first. X equals ln y divided by ln x. Again, that's the change of base formula for logarithms to be able to do that. Now, I think at this point, I can take the derivative with respect to x. So let's see how this works. So the derivative of x would be 1. And over here on the right, we have a quotient rule and implicit with this y over here. So I'll first take the derivative of ln y with respect to x. And that will be 1 over y dy by dx, and that'll be multiplied by ln x minus, I'll take the derivative of ln x, which is 1 over x times ln y, and that'll be over ln x squared. Okay, so all I have to do is solve for dy by dx. And I think I'm able to do that with the way this is presented here. So let me simplify some of this stuff in the numerator here. So let's see, 1 equals 1 over y dy by dx times. So let's say ln x is being times ln x. Let's say ln x over y. So ln x over y dy by dx minus ln y over x. That's multiplying 1 over x times ln y over, or actually, let's multiply by ln x squared. So let's say this equals ln x squared. So get rid of that 1. Okay, let's see what goes on now. So, well, actually, it's pretty simple to solve for dy by dx now. So I'm going to move the ln x over y over. So ln x, and ln y over x over. So ln x over y dy by dx will equal ln y over x plus ln x squared. And now all we have to do is multiply by y over ln x. So dy by dx is y over ln x times ln y over x plus ln x squared. Lastly, it looks like everything is going fine. The last thing we would like to do is rewrite y back in terms of x. So y was x to the power of x. So this would be x to the power of x over ln x times x ln x over x. So that's ln x to the power of x, which is x ln x. That's going to cancel, plus ln x squared. So it looks like the final solution would be x to the x over ln x times ln x plus ln x squared. Well, I guess we can still simplify it, because if we multiply by this ln x, that'll become 1, and then that will become ln x to the first power. And then if we distribute the x to the power of x, it'll be x to the power of x plus x to the power of x ln x. All right, so it looked like the first try worked. So there you have it, ladies and gentlemen, the derivative of x to the power of x.
Specialized in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe-to-toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.